This is the second segment about calculations related to light. This one is about how to find the index of refraction or the speed of light in a material. The formula we're going to be using is n equals c divided by v. N is the index of refraction. The index of refraction is a property of a material. Once you know it for all future problems. So for instance, if I tell you that the n value for water is 1.33, that means in every problem you work with water, that will be the case. N will equal 1.33. Now I don't expect you to memorize these values, but I will tell them to you in certain problems and expect you to use them in subsequent problems by referring back to the value given previously. So just be aware of that. The n value should be anywhere between 1 and 4. It should never be a very large number for any naturally occurring material. So that's the left-hand side of our equation, the n value. It is, again, a characteristic of the material. The right-hand side is a ratio of velocities or speeds. The top part is the speed of light in vacuum. By vacuum, I mean empty space. And it is the fastest thing in this universe. Nothing goes faster than the speed of light in vacuum. The denominator is the speed of light in the material, and that will change depending on what the material is. In fact, the higher the n value, the lower the speed of light in the material. Sometimes we say the speed of light in the medium. It means the same thing. You can see that this is the case, that the higher that n gets, the lower that v will be, simply because they have an inverse relationship. This means that something like diamond, where the index of refraction is 2.42, will really slow down light a lot more than air does, which has an index of refraction very close to 1. And that means that it's almost traveling as fast in air, light is, as it does in vacuum. Well, let's get down to an actual calculation here. In this particular problem, we're asked to find the speed of light in ice. So let's write down our equation. Actually, let's write down our given information first. N equals 1.31 for ice. C always equals 3 times 10 to the 8th meters per second, a value I will give you. And v is the unknown quantity here. What is the speed of light in ice? N equals c over v. Every single time, that c is going to be 3 times 10 to the 8th meters per second. So we're solving for v here. I'm going to rewrite my equation solving it for v. V is going to be equal to c over n. That's 3 times 10 to the 8th meters per second divided by 1.31. That in turn equals 2.29 times 10 to the 8th meters per second. I hope you're noticing that the value for v, even though I've said it slows light down, that ice does, it's still a very large number. 229 million meters per second. Nothing to sneeze at. So v and c will always be very large numbers, but n will always be a very small number, and it's helpful to know that. If you'd like to try your hand at some problems that are like this in the homework, then take a look at problems number 1, 5, and 6, and look also at concept number 27. These problems all have to do with the index of refraction. The next thing we're going to do in the third video segment is take a look at how we use the index of refraction in a calculation relating to how light bends when it passes from one medium to another.